Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to learn algebra. Today is our lesson number 151. We are in the process of solving word problems from day 101 through 200. Today is our 51st day of problem solving. Let's take a look at it, what we have today. Give me 1 second. I'm still here. Okay, let's see what we have for today. Before I start the problem for today, let me ask you this question. If I simply write this as x, y, z, in the language of algebra, what does it mean? X is some number, obviously, y is some number, and z is some number. And when it's written like this in the language of algebra, it is same as x times y times z. This is another way of writing the same thing. Or x, or a third convention, the third system, is to put dots in between variables. So x dot y dot z means x times y times z, or x times y times z, or x times y times z. If I had meant to portray the sum of those three variables, we would have written like this: x plus y plus z. But because there is no operation in between, it is assumed that they are being multiplied. This is just an assumption we make in algebra, in the language of mathematics, that if it's multiplication, then you don't have to put the multiplication. PQ means P times Q. That's all. Keep that in mind. Okay? Let's do the problem for today, and you'll see where we're going with it. A three-digit number is made up of digits x, y, and z. You see where we're going with it? The question simply is x, y, and z reading from left to right. Question simply is what is the number? How do we express that number in the language of algebra? Which is why I started out the way I did. X, y, and z reading from left to right. We cannot simply write that as x, y, and z. This is not a three-digit number. These are three numbers being multiplied together. This is not a three-digit number. For example, if we were to plug in, let's plug in here. Let's plug in here. Let's pretend that our x and y and z is 7, 8, and 6. Or 7, 8, and 3 if you like, doesn't matter. In the language of arithmetic, of course, in the language of arithmetic, if somebody were to come up to me and write something like this, 783, well, that's 783. It's 783. 783. How do we know that? Because this is in the 100 digit. We have 100 digit in 7. We have 8 in 10 digit. And then we have 3 in unit digit. And we understand that. So when we say 783, 783 actually means 783 actually means 7 times 100 plus 8 times 10 plus 3. This is somehow we have to express our three-digit number. So if it is x, y, and z reading from left to right, Then the leftmost is x, which is x times 100, plus y, which is y times 10, plus z. This is our 3-digit number. The 3-digit number that they're asking, what is the 3-digit number? The answer is this. The 3-digit number is x times 100, y times 10, plus z. Of course, we cannot leave it like this. We have to simplify it. We have to write it in a more refined form. X times 100 is written as 100x. Y times 10 is be written as 10y plus z. There you go. There is your 3-digit number. So now what it says is that, you give me the values of these 3 variables, x, y, and z, and I will tell you what the number is. So if x happens to be 7, you plug in 7 for x, 7 in place of x, and we get 700 times 7, plus if y happens to be 8, we get 10 times y, which is 8, plus 3, and the number would be 783. That's all. That's how you write a 3-digit number, starting from left, reading from left to right, if the 3 digits we are told are x, y, and z. If the 3 digits are x, y, and z. What would have happened? What would have happened if we were to reverse? What would happen if we were to reverse? If we were to reverse the digit? Let's talk about it for a second. Let's leave it alone the way it is. We're going to erase all this part that we don't need. And let's do this work here. What number would be formed if the digits are reversed? Well, if the digits were reversed, then our 783 will become 387. Now keep in mind, x, y, and z reading from left to right. So now we're reading from right to left. So z ends up here. This is our z. Our y stays the same because y is in the middle, and our x ends up on the right hand side. So now the new number that we form is 3 times 100, because this 3 is in a 100 digit. It's 3 times 100. Similarly, this is z times 100 plus this 8 is 8 times 10. So this is y times 10, because y is in the 10 digit, and finally x. And of course that will be written as in this simplified form. That will be written as z times 100 is 100z, y times 10 is 10y, and of course x. So as we notice, nothing happens to y. Y's position is still this middle one, obviously, because it's a 3-digit number. Had it been a 4-digit number, everything would have been messed up, reading from left to right and right to left. But it's a 3-digit number, the middle one doesn't change. And our z, which was a unit digit before, now becomes a 100 digit, so it's 100 times z. So now the number that we have is, if somebody were to ask you, what is the number? If somebody were to come up to you and say, our 3-digit number is made up of digits x, y, and z, reading from right to left, what is the number? Reading from right to left, what is the number? And so, to which you will say, the number is 100z plus 10y plus x. Reading from left to right, the number is 100x plus 10y plus z. That's all. That's how you write a 3-digit number. A 10-digit number, let's do one quick one here. Not a 10-digit number rather. A 2-digit number made up of P and Q, reading from left to right, P and Q cannot simply be written as PQ. This is not the number. This is not how we can do it. It has to be written as 10 times P plus Q. So now, you give me the values of P and Q and I'll tell you what the number is. For example, if you tell me that P is 3 and Q is 4, then this is 34. If you tell me that P is 7 and Q is 1, well, if P is 7 and Q is 1, 70 plus 1, 71. You give me the values of P, variable P and Q, and I'll tell you what the number is. But you cannot simply say PQ. That's not a two-digit number. No, sir. That is not a two-digit number. That's just P times Q. Do you understand? That is not a two-digit number. That's simply two variables being multiplied together. That is all I have for today. That is all I have for today. I'll see you tomorrow on day number 152, where we'll talk about how to take the sum of consecutive numbers, or 3 consecutive numbers, in the language of algebra, obviously, not in arithmetic. Arithmetic is very straightforward. You plug in the values for these variables and it comes out very simply. I'll see you tomorrow, okay? Bye now.